Alright, hey, how's everyone doing? Today we'd like to present you our Acme Footwear Case Study Project by myself, Courtney Craig, Weston Zeller, and also William Wallace as well. Let's get it. Alright, here's the main thing. Acme is the wholesale footwear distributor. Their current distribution center in out west Arizona is at a storage and throughput capacity. The growth of this location is restricted. Thus, Acme has requested that we design a new facility to meet their future needs. All right, here's the rundown. Here's the problem. Acme's current distribution center is at a maximum storage and throughput capacity. The current location is landlocked, eliminating the ability to expand, and that's no good for us at all. Additionally, the current location's lease expires in July of 2017, but Acme is thus seeking options for a new facility design and location by the end of 2016. That's why they came to us. The new facility must accommodate a growth through 2021. This growth must factor a 7% annual unit growth and a 2% annual SKU growth. Lastly, it wishes to stay near the current location in out west Arizona.
So now we move on to the product flow. Our data analysis gave us the following key variables by the end of a 5-year planning period for the end of 2021. Initially, we started with 33,183 SKUs. Given a 2% SKU growth for a 5-year planning period, we came out with 36,637 SKUs at the end of that time. This gives us roughly, or using the same growth calculations, this gives us a rough estimate of just under 168,000 average units shipped per day, with a maximum unit shipped per day of just over 576,000. In addition to this, our on-hand units grew from just over 7.2 million to just under 11.2 million by the end of 2021. The weighted average distance of the facility to any SKU is roughly 529 feet, so that's sort of the centroid of the entire storage area. The largest change to the product flow was the utilization of cross-docking. This allows for high traffic items to remain at the front of the facility for minimal operating costs. These are items that go in on a daily or bi-daily basis. The remaining products were allocated to the forward and reserve categories based on their SKU velocity. And we'll talk a little more about SKU velocity here shortly. It's categorized in an A, B, C, D, and E level of importance.
For equipment selection, based on our data analysis, we comprised a selection of Toyota products to meet the desired needs. These include 10 Toyota Core forklifts, electric and gas-powered, 6 Toyota 6 Series order pickers, 6 Toyota electric walkie pallet jacks, and 2 Toyota hand pallet jacks. The Toyota equipment was selected based on reliability and competitive pricing in addition to a wide range of equipment selection. So we showed you the overall numbers on the previous page, but these are the calculations for those numbers. We took the total daily flow and broke it down into cross-docking, forward, and reserve, and then we found out the total distance needed to move by each pallet, electric, and forklift and order picker. So then we calculated the max speed of each of these and then took an average considering stoppage time and corners and acceleration. And then we calculated the feet per day. And we based the number needed from the total distance moved on the feet per day. And then we have forklifts and electric pallet jacks for the loading and unloading, and we used 4 for both of those.
Okay, now for space utilization. Based on our data analysis, we determined a total of approximately 3,271,633 cubic feet of storage space was needed. This is just storage space for the actual SKUs themselves. To achieve this, we utilized a pallet and carton storage system. This was done using pallet racks compatible with both pallets and cartons. This saves money, saves time, saves space, and makes the overall process a lot more simple. These are approximately 21 feet tall, capable of stacking 5 pallets high and 4 wide per individual rack. The minimum aisle width we went with is 12 feet. This accommodates the minimum turning circle for our forklifts. The forklifts are our largest pieces of equipment, and they have the largest turning circle, so accommodating them is the bare minimum. Main aisles that are very high traffic areas reach as much as 25 feet. These are areas where forklifts are passing side by side more often than a regular aisle. The floor area for storage is roughly 797 feet by 649 feet, with a minimum recommended ceiling height of 40 feet for the appropriate clearance. This allows for building beams, lights hanging down, and stuff for clearance between the top pallet racks. This creates a total floor space for storage alone of 517,253 square feet. So now for the new facility layout. The new facility layout was determined from numerous factors. The largest change was the utilization of cross-docking for high-flow units. Cross-docking comprises of only 873 SKUs, roughly 2.1%. These are all units that ship out more than 150 days of the 249 working days per year. This is indicated by red in the next slide on the diagram. The forward area is comprised of the remaining SKUs that are of A, B, or C importance in the SKU's velocity category. These are indicated by orange. The reserve area is comprised of the remaining SKUs of D and E velocity, which we show in cyan on this next slide. So here we have the actual facility layout diagram. As mentioned, the red here in the front is for the cross-docking units. This also includes the on-hand units for those same SKUs in order to reduce shipping times any time of the year if a unit does need to stay for more than a day or two. Next is the orange, which is the forward area. This is comprised of the remaining A, B, and C velocity category units. This is the bulk of our items. Roughly 51% of our total volume is in the forward area. And in the back, you see in the cyan color is the reserve. We added diagonals to this area for reduced distance to the far corners of this section. And also you'll notice that these racks are double width versus the forward and cross-docking racks. The reason for this is these items are not touched very often, and when they are, it's not very many items, so we can afford to take a small amount of time to move something out of the way if necessary. In the rare occasion you do come back to this area. So as mentioned, these are double wide, so each little rectangle represents one pallet rack that is 4 wide, and that pallet rack will hold 5 high, so a total of 20 pallets per pallet rack. This red diamond in the middle here represents the overall centroid of the facility. It's a weighted point, so it takes into account that the cross-docking items here are more important than the forward items, and the forward items are more important than the reserve items. Lastly, down here in white are the shipping doors, both for in over here and for shipping out over here. We also overhung one door on each side for the cross-docking. This allows the cross-docking to be utilized and accessed faster, reducing time and saving money.
For the operational plan, loading and unloading of trucks will be designated to forklifts and electric walkie pallet jacks. Forklifts will also be utilized for all palletized items on the second row of the pallet racks or higher. Order pickers will load and unload cartons on the second row of the racks or higher. Pallet jacks, both electric and manual, can be utilized for ground level pallets and cartons. Manual jacks are primarily for short distance areas such as cross-docking. The operation process itself remains mainly unchanged, with the primary change being the utilization of cross-docking. This allows for fast and easy transitions between the loading and unloading.
All right, now here we have our implementation plan. Transferring facilities with the amount of on-hand units without affecting the existing activities will not be possible. Time will be needed to close the old facility in order to relocate existing on-hand units to the new facility. So pretty much our suggestion is to transition during closing days, such as holidays and weekends or low volume days throughout the year, such as the beginning of November is when their production was at its lowest. And that would be a perfect time to basically transfer to the new facility based on last year's order flow.
For the economic justification, Due to lack of initial information regarding the current facility's operating costs, we were not capable of making an economic comparison. Thus, the justification of our plan is based on efficiency of space and equipment utilization. The largest difference in the facility is the utilization of cross-docking. This addition will greatly decrease operating costs while also decreasing facility cost. Measures were taken to use efficient equipment such as electric operated forklifts and pallet jacks to reduce operating costs. Also, we made sure that the minimum amount of equipment was used through calculations. The facility was also designed for maximum storage volume while using a minimal facility floor area. In conclusion, our major findings were that we had about 3.3 cubic feet of storage space needed to accommodate all 5 years of growth. This will be done using approximately 500,000 square feet of floor space. The average weighted distance to pick up or rack any SKU is approximately 529 feet. The average weighted distance to cross-dock area is 350, to forward area is 580, and to reserve area is approximately 800. Our recommendations: we recommend adding cross-docking. We also recommend organization of SKUs based on daily flow and SKU velocity category, and we recommend a closing period to relocate to the new facility. Our facility is designed to be as cost efficient as possible from both area usage, equipment utilization, and distance standpoint.
Thank you for taking the time to listen to our presentation. We hope you enjoyed it.